Okay, so yesterday we started chapter 9, talking about how to solve quadratics. We basically found that the balancing method, like when you solve linear equations, rarely works. Okay, either the bx term would need to be missing, or the c term would need to be missing for you to be able to use balancing. We also found out that factoring works sometimes, but sometimes the problem is not very easily factorable. But a technique that will work every time is to complete the square. It's just a little bit tedious. Okay, so when we look at question number 1 on this paper, where it says solve the following equations for x without graphing, hint, think factoring, completing the square, I'd like you to try to work each of these out. So I'll go ahead and print out your paper and go ahead and work out each problem, and then I'll kind of show you how to work through these so you can check your work. Okay, it's really important that you understand this idea of completing the square to be able to solve. Okay. All right, so the first thing that you might want to do when solving a quadratic is, just in case you wanted to try to factor it, you probably want to set it equal to 0. So I'm going to start with x squared minus 6x. I'm going to subtract 3, so I get plus 7 is equal to 0. It's still the same equation, but a little bit different format, okay? I could try and factor it, but actually, if you start that whole process, you're going to find out it doesn't factor. So I'm just going to go straight to completing the square. So remember, with completing the square, you're going to go ahead and take your x squared term, put it here. You're going to take your bx term, which is in the middle, and you're going to split it. I'm going to put negative 3x here, negative 3x here. So x, negative 3, x, negative 3. That means my corner would have to be negative 3 times negative 3, 9. I only have 7 tiles to put in here, so I'd need 2 extra. So I'd be short 2, so I'd have to say minus 2 equaling 0. Okay, so these two numbers together have to equal that one. All right, so when I complete the square, it looks like x minus 3 squared minus 2 equals 0. Okay, and now I'm going to try and solve from here by undoing. I'm going to add 2 to both sides. So I get x minus 3 squared is equal to 2. I'm going to go ahead and take, so what number squared is 2? I'm going to take the square root of 2. So x minus 3 is equal to either the square root of 2 or x minus 3 equals negative square root of 2. I'm going to add 3, add 3. So x is equal to 3 plus the square root of 2, or x is equal to, add 3, 3 minus the square root of 2. So these would be my two values of x that would make this true. Okay, and you could find a decimal approximation if you wanted to. All right, so go on to B, and let's go ahead and try that one by completing the square. M squared here. I'm going to split my 12m and make it 6m, 6m. So I've got m, 6, m, 6. 6 times 6 is 36. Okay, this is 37, so if I put 36 tiles in here, I'd have an extra 1 here, so I'm going to say plus 1 equals 0. So then in kind of vertex form, I've got the equation m plus 6 squared plus 1 equals 0. Okay, I'm going to try and solve from here. I'm going to subtract 1 from both sides, so I get m plus 6 squared equals negative 1. Okay, so let's see what happens here. What number squared is equal to negative 1? Okay, well, there's no real number that when squared equals negative 1, and if I try and take the square root of negative 1, I get no solution. So actually, this equation is not solvable. Okay, so no solution here. Okay. Can you imagine what this would look like when I graphed it? So I'm just going to use x here, though, instead of the m. So x squared plus 12x plus 37. I'm going to do zoom 6. Okay. Can you tell that it doesn't ever equal 0 here? Okay, so it's possible that when you're just like at the linear, you can try and solve it and there might not be any solution. In this case, there's none. Okay, so let's try and solve C by completing the square. Okay, first I'm going to set it equal to 0. Okay, and just kind of, then I could think about using the zero product property, which actually would work in this case. It could factor. Okay, but I'm going to go ahead and just more practice with completing the square. So I'm going to do k squared. I'm going to split my negative 16k into negative 8k, negative 8k. So I get k minus 8, k minus 8. Negative 8 times negative 8 is 64. Okay, I only had negative 17 squares, so I'd need to add all my 64, so I'd have to subtract 64. Okay, so that would mean I would need to do minus 81 equaling 0. Okay, so 64 minus 81 would equal my negative 17. Okay, so this is going to be k minus 8 squared minus 81 is equal to 0. I'm going to do k minus 8 squared. I'm going to add 81 to both sides. And then what number squared is equal to 81? So I'm going to just take the square root of 81. So k minus 8 is going to either equal 9 or k minus 8 is going to equal negative 9. So if I add 8, I get k is 17 as one solution. If I add 8, I get k is equal to negative 1 as my other solution. Okay, so those would be my two values. Okay, and it would actually have been factorable when I decided to complete the square. Okay, so do you remember from yesterday when I said completing the square is kind of tricky? If what? So what makes this one a little tricky? So how is equation D different than A, B, and C? Okay, so if I try and complete the square, I'm not starting with just an a value of 1. So if I'm making a square in the bottom, and if I had 2p squares, I would actually have to take the square root of 2p on each side to get multiply it. So it would make it kind of complicated to complete the square with that 2. So I'm going to go ahead and I'm just going to divide everything by 2. Everything, okay? So it makes that square in the corner a little easier if I don't have an a value that's just 1. So I've got p squared is equal to 18p plus 40 equaling 0. Okay, so now I'm going to complete the square of this one. It might be a little easier. So p squared, I'm going to split my 18, 9p, 9p. So I get p, 9, p, and the 9. 9 times 9 is 81. I've got 40 squares already, so I'd need to add an extra 41 to complete the square. So I'm going to subtract 41, and I get 0 here. Okay. All right, so I've got p plus 9 squared minus 41 is equal to 0. I'm going to try and solve from here. I'm going to add 41 to both sides. So p plus 9 squared is equal to 41. Okay, so p plus 9 is equal to the square root of 41. Or p plus 9 is equal to negative square root of 41. I'm going to subtract 9. So I get p is equal to negative 9 plus the square root of 41 as one solution. And I'm going to subtract 9 here. So I get p is equal to negative 9 minus square root of 41 as my second solution. Okay, so those are the two solutions to D. Okay. So I kind of hinted on question 2 because I just sort of forced that one. Which method, factoring or completing the square, should work every time? Okay, well, sometimes we've seen this already. Sometimes an equation in standard form will not factor. Okay, so you can always complete the square. So completing the square works every time. Okay. You can always take and split the middle term and then add into the corner to get that in the format. And then once you've got it from there, you're not going to run into the problem of having your x squared and your x really separated anymore because they're in that perfect square. Okay, so when is completing the square difficult to do? Okay, well, it's almost kind of tedious about every time, but it's especially tedious if you have an a value that you've got to deal with. Like let's say I had 13x squared plus 15x minus 22 equals 0. I'd have to start by dividing everything by 13, and that's going to make kind of a mess out of this. I'd end up with like a lot of fractions that I'd have to work with, okay? So having some kind of a value other than 1 makes it kind of messy, okay? If you have decimals, it might be messy. So even if my a value is 1, if this is, say, plus 37.52x minus 375.1 equaling 0 or something, I have to start by splitting that and then squaring that and then figuring out what that extra part is. Okay, so it can get pretty tricky if there are decimal values, and especially if there might be, some non-whole number or integer values for a, and I have to divide and, break up my b and my c into numbers that are a little bit more difficult to work with. Okay. All right. So even though it works every time, it can be kind of complicated. So we're going to learn another method of solving a quadratic and that will work every time. Okay. And it comes from understanding how you can complete the square with any quadratic in standard form. Okay. So this is pretty complicated. If we were in class, I'd probably just give you this and just say, go play with it. See if you can try and complete the square with using A, B, and C instead of numbers. Okay. All right. So, but I think I'm just going to kind of, stop. You'll have some ed puzzle questions kind of in the middle that I'll ask you some things to do, but we're going to get to it by looking here. Okay. All right, so if I was going to try and complete the square with a standard form equation, the first thing I'd probably do is get rid of this a to make my square a little easier. So I'm going to divide everything by a. Okay, so when I divide this equation by a, I get x squared plus b over a x plus c over a equaling 0. Okay, so I kind of achieved the first thing that I did on all those example problems on the previous page. I made my a value 1, which makes it a little bit easier to complete the square. All right, so I'm going to go ahead and try and complete my square. All right, I'm going to stick x squared here. And then I'm going to take and split my BAX. I'm going to take this in half. Okay, so I'm going to take half of each of those. So I'm going to write this as 1/2 B over AX, 1/2 B over AX. Okay, right there. All right, so then I'm going to make this X and X. Okay, and then I'm going to go ahead, and this is really just B over 2AX, isn't it? And so I'm going to put B over 2A, B over 2A. My corner is found by taking B over 2A times B over 2A. So B times B is B squared. 2A times 2A is just 4A squared. Okay, so remember, if I was working with tiles, I'd need all those, so I'd have to also subtract them off to add them in here. So I'm going to subtract off what I just added here. Okay, and then I still have my plus C over A equaling 0. Okay, so now I'm going to try and write this in perfect square form. Okay, so I've got X plus B over 2A squared minus B squared over 4A squared plus C over A equaling 0. Okay, so now I've got it in perfect square form and I'm going to try and solve it. What do you think I'm going to do next? Okay, so if I was working with numbers, I'd go ahead and move this over here, okay, by adding the opposite to both sides. So I've got X plus B over 2A squared. Okay, when I move this over here, this becomes B squared over 4A squared minus C over A. Okay, so I subtracted those from this side and subtracted those from 0. Okay, now this looks kind of messy. I'm going to try and just make that into a single fraction. So in order to add fractions together, what do you need? You need a common denominator. So how could I get a common denominator right here? What if I multiply this by 4A over 4A? Do I now get a common denominator of 4A squared? Yep, I do. So I've got X plus B over 2A squared equals Okay, common denominator, and I would just combine the numerators if I'm subtracting. So I've got b squared minus 4ac all over 4a squared. Okay, so all I did was combine these two fractions together. All right, so then what squared is equal to this? So I'm going to go ahead and take the square root of this. So I get x plus b over 2a is equal to plus or minus, because it could be a positive or negative that, squared, b squared minus 4ac over 4a squared. Okay. So again, I'm trying to solve for x, so I'm going to go ahead and subtract this. So I've got x equals minus b over 2a plus or minus b squared over 4ac. Okay. All right. Now I can simplify this a little bit further. Okay, I'm taking the square root of this fraction. The top I can't really do much with in terms of simplifying, but 4a squared is actually a perfect square, so I can split my fraction and write as b squared minus 4ac. And what is the square root of 4a squared? So what times what equals 4a squared? 2a. Okay, now notice the denominator is the same. So now I can add these fractions and kind of condense it a little bit more. So I get x equals negative b plus or minus. So if I was combining fractions, I keep the denominator the same, and then I combine the numerators. And then ta-da! Have you seen that before? Yeah, that's the quadratic formula. Okay, so basically the quadratic formula comes from taking the standard form, okay, oops, taking the standard form of a quadratic and completing the square, okay? So I'm going to go ahead and I just try and complete the square with ax squared plus bx plus c equaling 0. Okay, so it's the same technique that I was using, okay, when we solved all of these earlier, okay, but now I just did it in general, what would happen every time. Okay, so and then on Thursday, we'll talk about, so what? Okay, why do you want to know the quadratic formula and how is that going to actually help you?